Hello everyone, in this video we're going to talk about some things you learned from your exploratory activities about transformations, and then we're going to talk about symmetry. So the first thing we're going to do is talk about the transformation rules you hopefully discovered or suspected in looking at the activity, the exploration activity, and then we'll talk about ways we use transformations in symmetry. So, as you may remember, there were four types of transformations we looked at. First, there were slides or translations. Then there were reflections, which we can think of as flips. We had the rotations, which are sometimes called spins. And then we had the dilations, the growing or shrinking. Now, you may wonder, why do we care about these? So there's a couple reasons these are used in some interesting applications. In terms of Utah state standards, or the things that teachers in Utah are required to teach, these things are covered in 8th grade. Now, many of you are thinking, I'm only going to be licensed to teach math through 6th grade. You're right, but the geometry you teach in the younger grades will help prepare students directly for these things. Specifically, you'll notice that the way we define congruence in 8th grade is through a series of rotations, reflections, and translations. In other words, we define something as being congruent if you can somehow lay one triangle on top of the other. Similarly, we defined, you may remember us talking about the perspective view of similarity. That was me essentially trying to shoehorn this definition of similarity in, where similarity comes through a sequence of rotations, reflections, translations, and dilations. Essentially, you lay them on top of each other, with one having to be shrunk or stretched in order for them to match. Let's talk about the rules you hopefully found. So first, we found that with a translation, there's usually some sort of direction. We call that direction A, comma, B. Or in other words, you move A left or right, and then B up or down. So in this case, our original points on our figure start at some coordinate x, y, and go to x plus a, y plus b. So let's say I'm moving the point 1, 2 by, I don't know, -2, 3, so that's 2 left, 3 up. That means my image, or my new point, is going to be -1, 5, where I take the 1 and add it to -2, and the 2 and add it to 3. Now, for flips, if it's an x-axis reflection, the y value changes. X, y goes to x, -y. And then for a y-axis reflection, we flip the x value. And in the next video, we're going to explain why that is. Now, for rotations, we talked a lot about counterclockwise rotations in multiples of 90 degrees. So for counterclockwise rotations for 90 degrees, we found that xy turns into -y, comma x. Hopefully you saw that pattern and playing around in the exploration activity. with 180-degree rotation, we found that xy went to negative x, negative y, and then with a 270-degree counterclockwise rotation, we have xy going to y negative x. And these are all for counterclockwise rotations. Now, we found that with dilations, if my scale factor was a, xy went to a times x and a times y. Now, in the next couple of videos, you're going to see why that is.